Induced EMF in metallic rod rotating in uniform magnetic field. So here PQ is metallic rod and this is metallic rim and there is uniform magnetic field. The length of the rod is L and it is moving or it is rotating with angular velocity omega. So suppose time period equal to T, then change in flux equal to magnetic field times area swept. Here, area swept will be pi L square. So it will be equal to B times pi L square. Now induced EMF equal to change in flux per unit time. So d phi by dt, we are considering magnitude of EMF. That is, here we will not write d phi by dt. Instead, we just write this B into pi L square divided by, we will take dt as time period t. But 1 upon time period is frequency. So we can write E equal to B pi L square times F. We know that angular frequency omega is given by 2 pi F. So we can replace F by omega upon 2 pi. Then we will get E equal to B pi L square to omega upon 2 pi. So pi will cancel out and it will be 1 by 2 B L square omega. Now, if you want to find out induced current, so I equal to E upon R. So it will be 1 by 2 B L square omega divided by R. And suppose we want to find out heat dissipation, that is Q, which is heat dissipation, means heat lost. So that will be equal to E square R divided by T. That is E square resistance is R divided by T. We put the value. So square of E, that is 1 by 4 B square L power 4 omega square, and then divided by R. So this will be equal to Q equal to 1 by 4 B square L power 4 times omega square T divided by R. Now let's understand this concept by taking some examples. So question number 1. A wheel with 10 metallic spokes, each 0.5 meter long, is rotated with a speed of 120 revolutions per minute in a plane normal to Earth's magnetic field at that place. If the magnetic field at that point is 0.4 Gauss, then what is the induced EMF between the axle and the rim of the wheel? So here we are given length is 0.5 meter. Number of metallic spokes does not matter. We will not make use of it. And magnetic field is 0.4 Gauss, that must be converted into Tesla. So 0.4 into 10 to the power minus 4 Tesla. And frequency is given as 120 revolution per minute. So 120 divided by 60, that will be 2 hertz or 2 revolution per minute. Now we know that induced EMF is B pi L square times F. So we can put the values. 0.4 into 10 to the power minus 4 into pi, that is 3.14 multiplied by L square. L is 0.5 square into frequency, that is 2. So this will give 6.28 into 10 to the power minus 5 volt. As all the 10 spokes are connected with their one end at the axle and the other end at the rim, so they are connected in parallel, and hence EMF across each spoke is same. So number of spokes are immaterial, as I told you in the beginning. Now let's see next question. A circular copper disc 10 cm in radius rotates at 20 radian per second about an axis through its center and perpendicular to the disc. A uniform magnetic field of 0.2 Tesla acts perpendicular to the disc. Calculate the potential difference developed between the axis of the disc and the rim. And the second point, what is induced current if R equal to 2 ohm? So here we are given R radius, which means length, is equal to 10 centimeter. So here it is 0.1 meter, and angular velocity omega is given as 20 radian per second about an axis center. Here magnetic field is given as B equal to 0.2 Tesla. Now potential difference developed, as we know, in case of rotating rod in magnetic field, it is 1 by 2 B L square times omega. Here L is radius. So if we put the values, so 1 by 2, magnetic field is 0.2 into L square means 0.1 square times angular velocity is 20 radian per second. So instead of 20 radian, questions would have been 20 pi radian. So here we are writing 20 pi radian because this question was asked in CBSE where the frequency, this was omega was 20 pi radian. So I am modifying the question according to the question asked by CBSE. So 20 pi. So this will come out to be 0.0628 volt. Although this question can be calculated by putting 20 also. Now, induced current. Induced current I will be E upon R. So value of E is this much, 0.0628 divided by resistance is given 2 ohm. So this will be equal to 0.0314 ampere. Now let's see next question. So next question is a metallic rod of length I, sorry, instead of I, it is a metallic rod of length L and resistance R is rotated with frequency nu, with one end hinged at the center and the other end at the circumference of a circular metallic ring of the radius L about an axis passing through the center and perpendicular to the plane of the ring. A constant and uniform magnetic field B parallel to the axis is present everywhere. Derive the expression for the induced EMF and the current in the rod B due to the presence of current in the rod and of magnetic field. Find the expression for magnitude and direction of the force acting on this rod. Hence, obtain the expression for the power required to rotate the rod. So let's consider the question. This question is little tricky. So here a rod is rotating. When the rod rotates, then electrons move from this side to this side. So we can say that these electrons will experience the Lorentz force, and these electrons will get distributed on this outer periphery or on the circumference. And the magnitude of EMF generated across the length dl. This rod is of length L. So since electrons are moving, so we consider small portion, and then we will integrate to find the total length or total value. So the magnitude of the EMF generated across length dl of the rod as it moves, since this rod field is perpendicular. So as it moves at right angles to the magnetic field is given by, so here we apply small value dE equals, as we know, E equal to BLV. Here we are taking small value. So since we are writing dE, small value of EMF, so small length of rod will also be considered. So we write it BV dF. Now total value can be found by integrating it. So E equal to integration BV dl, and limit will be from 0 to L. 0 to L, and we know that angular velocity V equal to R omega. So omega will be V upon R. So here we have to replace V. So it will be R omega. So we write it, and the radius is equal to L. So V equal to L omega. So we put this value here, 0 to L, B and L omega times dl, and we integrate it. So integration x dx gives x squared by 2. So integration L dl will give L squared by 2. So B omega L squared by 2, limit is 0 to L. So this will be the same value. So 1 by 2 B omega L square, and we can write it further, omega equal to 2 pi and frequency nu. So we can put this value here. So it will be 1 by 2 B times 2 pi nu times L square. So 2 will cancel out, and then we will get pi nu BL square. Pi nu times BL square. Now we can find I. So I will be, this is the value of induced EMF. Now we have to find out current. So current is I equal to E upon R. So we have got E as pi nu times magnetic field times L square divided by R. And suppose we want to find out force, because next part is to find force. So force will be equal to B I L. So here value of I is this much. So we write it B L times I pi nu B L square divided by R. So it will become pi nu B square L cube divided by R, which is our answer. And there is one more part where we have to find out power. So power is given by E square divided by R. So EMF induces pi nu BL square. So it will be pi square nu square b square L power 4 divided by R. So this is our answer. Now let's consider next question. A conductor of length L is rotating with constant angular velocity omega in a plane perpendicular to a uniform magnetic field B. Plot graphs to show the variation of EMF induced across the ends of the conductor with angular speed and length of conductor L. So as we have done in previous question, the same method we will follow. E is equal to integration dE, which will be equal to 0 to L, and then BV dL, and then we replace V by R omega. Here R is length of the rod, so L omega. So we will get 0 to L B L omega dl. Then we integrate it. So we will get 1 by 2 B L square omega, as we have got in previous question. Now, clearly, E proportional to omega. It means with increase in value of omega, E will also increase. Here E is induced here. So graph will be clearly straight line. So this is E, this is omega. So graph will look like this. Now we consider second point. Here, if you observe, E is proportional to L square. So since E equal to 1 by 2 BL square omega, so this will give E proportional to L square. It means this will be a parabola symmetric to E axis. So it will be like this. I think you must have understood. Thank you for watching.